What is expectation? As a formula, we wrote this last time. The day we did uniform distributions, we did this.
Integral x times probability, capital X.
Why this, Nathan, and why not that?
Because that would be discrete.
Very good. So you can't put probability x is equal to x. It's not a discrete random variable. It's continuous. So we've got to integrate over the entire suppose 0 to infinity, x multiplied by the density. We know what the density is, lambda, e raised minus lambda x dx. Lambda is a constant. Can pull it out of the integral. How do we integrate that? Do we remember?
By parts.
Integral by parts or integration by parts. Sure, you could use integration by parts, but I'm just going to use the tabular method. It's going to be easy. So u is x, v is, or dv is e raised negative lambda x dx. Differentiate the first time, 1, differentiate one more time, 0, integrate e raised negative lambda x dx one time, it have e raised negative lambda x over negative lambda. Integrate it 2 times to have e raised negative lambda x divided by negative lambda times negative lambda. Do we know the tabular method of integration? Okay. So x multiplied by that term and 1 times minus multiplied by that term, so minus e raised minus lambda x divided by lambda squared. Good. And lower limit here is 0, upper limit is infinity. What happens to that term when you take the upper limit infinity? Goes to 1, upper limit is infinity. Would it blow up?
Well,
This is a linear rate that is exponential.
yeah,
So,
that goes to 0, the exponential part.
yes, and this will go to 0 faster than that. So that entire thing will become 0. And here, e raised negative infinity, still 0. So the upper limit is all 0. Minus the lower limit. If you plug in 0 here, that's going to go away. And you have minus e raised 0 is 1. So we'll have minus from the integration. The lower limit, when you evaluate the first term, I get 0. Evaluate the second term, I get minus 1 over lambda squared. And if I distribute the negative, I would have lambda times 1 over lambda squared, which is simply 1 over lambda. So the expectation of an exponential random variable is 1 over lambda. So the formula for variance is expectation of x squared minus expectation of x whole squared. We know the expectation of x part. We need to find expectation of x squared. And what is expectation of x squared? Using locus. Integral 0 to infinity, x squared e raised lambda e raised minus lambda x dx. Same process like we did over here, but you have one extra step because we have x squared instead of x. So use tabular integration by parts and tell me what the value of expectation of x squared is. So same process, integration by parts. So x squared and erase negative lambda x dx. Going to pull lambda out. Differentiate it first time, 2x, one more time, 2, one more time, 0, got to go all the way up to 0. Integrate it once, you'll have e raised negative lambda x over negative lambda. Integrate it one more time, e raised negative lambda x divided by negative lambda times negative lambda, positive lambda squared. Integrate it one more time, e raised negative lambda x divided by lambda squared times negative lambda minus lambda cubed. Always start with plus and alternate signs. So that integral would equal to lambda multiplied by x squared times that term, so minus x squared e raised minus lambda x over lambda, minus 2x times that term, so minus 2x e raised minus lambda x over lambda squared, 2 times that term, minus 2 e raised minus lambda x over lambda cubed. Now we apply the limits. Lower limit is 0, upper limit is infinity. For all those limits, when you take x approaches infinity, that will go to 0, that will go to 0, that will go to 0, because we have e raised negative lambda x. So lambda, upper limit, evaluates to 0, minus the lower limit, 0 goes in there, so 0, 0, 2, e raised 0 is 1, I'll have 2 over lambda cubed. Good. So I have lambda, if you distribute that negative, you'll end up having lambda times 2 over lambda cubed, which is 2 divided by lambda squared. Good. We found earlier that the variance is 1 over lambda. Excuse me, the expectation is 1 over lambda. We found expectation of x squared to be 2 over lambda squared. And we know that variance of x is that. So variance of x will be equal to 2 divided by lambda squared minus expectation of x, which is 1 over lambda squared. So 2 over lambda squared minus 1 over lambda squared, we get 1 over lambda squared. So the variance of an exponential distribution is 1 over lambda squared. The expectation or the mean is 1 over lambda. Good.